Here are the solutions to questions 57, 65, 75, and 78, A and B. So, what's the flaw in the design of this experiment involving drinking cocoa with flavonols in it and blood flow? So, the primary issue is this experiment had no control group. Everybody was treated with the same cocoa with flavonols in it. So there's no basis for comparison. So maybe that significant improvement that was reported was just due to the placebo effect. We observed improvement because we expected to observe improvement. We were being treated. So a better design, the question didn't ask you to describe a better design, but I'd like you to think about it anyway. A better design would have been to have randomly assigned subjects to two groups. You would want a treatment group where subjects consume the cocoa beverage with flavonols in it. And then you also want a control group where subjects consume a cocoa beverage without flavonols in it. So it's important to have two treatments. So the second treatment without the flavonols, that's a placebo. So this way the placebo effect can act equally on both groups. In other words, both groups are being treated, so the placebo effect acts equally on both. So the idea being, if we see more improvement in the treatment group that really has the flavonols, that means that that extra improvement we can conclude may very well be caused by those flavonols. So something to think about. An experiment is called a single-blind experiment if the subject doesn't know the treatment they're receiving. So using a placebo, like in this case, the cocoa beverage without any flavonols in it, as long as the subject doesn't know which treatment, which cocoa beverage they're getting, this experiment can be considered single-blind. Now, a double-blind experiment is even better because the subject does not know which treatment they're receiving, but the experimenter is also blind in the sense that the experimenter also doesn't know which treatment the subject is receiving. So the experimenter would be the person that's actually giving the cocoa to the subject. So there would have to be a third party that's keeping track of which subjects are in the treatment group and which subjects are in the control group. So that third party, which is tracking who is in which group, they would be responsible for giving the experimenter the cocoa beverages without telling the experimenter which is which, but telling the experimenter which beverage goes to which subject. The idea of a double-blind experiment being you wouldn't want the experimenter to accidentally make a joke, for instance, give the subject their treatment and say, hey, enjoy your flavanol. Oops. Now that subject would know that they're getting the real treatment. That's the idea. So a double-blind experiment is really the gold standard. That's the way to go. So the headache relief question, you're just giving a description of a completely randomized design for this question. So again, I like to use the hat method. It's not the one people would typically use in practice, but it's the one that's easiest to describe if you're writing a question on the AP exam. So all 36 subjects' names go on slips of paper, put them in a hat or a container, shake the hat, and mix up the papers. So select 9 of them from the hat. There are 4 treatments, so 36 divided into 4 equal parts is 9. Select 9 slips from a hat. Assign those subjects to the antidepressant alone treatment. Select 9 more slips from the hat. Assign those subjects to the placebo alone treatment. Select 9 more slips from the hat and assign those subjects to the antidepressant plus stress management treatment. The subjects on the remaining 9 slips are assigned to the control group, which is the placebo plus stress management treatment. So understand that's the best we can do in terms of a control group. You can give them a placebo instead of giving them a real antidepressant, but there's no way to put subjects into a stress management class and at the same time have them not realize that they're in a stress management class. There's really no way to create a placebo for a stress management class like there is to create a placebo for a pill. So something to think about here, I used the words in the question to write this answer. So what I put in quotes, it is perfectly okay to just copy what you see in the question in order to include the context. That's also what I did here. So notice what I put in quotes at the end. At the end of the study, compare the, quote, number and severity of chronic tension type headaches between the 4 groups. I appreciate that none of you may actually write that way. I wouldn't write that way. But you might as well work efficiently. So what I put in quotes there, number and severity of chronic tension type headaches. Literally, I just copied that right out of the question. You're perfectly welcome to do that in an assessment in our class. Same thing on the AP exam. Using the words in the question is a great way to get context into your answer and to write an accurate answer. Question 75, doctors and nurses. Actually, it's doctors and nurse practitioners. So, which are the blocks in the experiment? The chronic conditions are the blocks. There's a group of subjects that have asthma. There's a group of subjects with chronic diabetes. There's a group of subjects with chronic high blood pressure. So those 3 chronic conditions are the blocks. And it's important when you create a block to remember that in a block, you want to put all of the subjects that are similar. So all the asthma sufferers together, all the diabetes sufferers together, all the high blood pressure subjects together. Blocks create groups of subjects that are similar, and the characteristic used to make that block should be a characteristic that you believe might affect the response. So maybe the difference between these kinds of chronic conditions might affect the response to having a doctor or a nurse be your caregiver. So we also know that these are the blocks because when you read the question says that patients within these condition groupings were randomly assigned to either see a doctor or a nurse practitioner. The random assignment occurs within the block. So if the random assignment occurs within these groupings, that means these groupings, asthma, diabetes, and high blood pressure, those are the blocks. So part B, why is a randomized block design preferable to a completely randomized design? Well, without the condition blocks. So if you have the asthma sufferers, the diabetes sufferers, the high blood pressure sufferers all mixed up together and you're simply randomly assigning them to the doctor treatment or to the nurse practitioner treatment. So when you see differences in health measures or in differences in satisfaction between the treatments, maybe that's due to the treatment, whether they're seeing a doctor or a nurse practitioner, or it might also be due to the challenges brought on by the underlying condition that you're not controlling for. If you don't have blocks, you're not controlling for that underlying condition. So maybe satisfaction is always lower for people that suffer from diabetes for whatever reason, if that health condition is more difficult to treat. So we can better trust the comparison between the treatments, the outcomes that we see with a doctor or with a nurse practitioner. So we can better trust the comparison if the comparison is done within each block. So we do the comparison 3 times within the asthma block, within the diabetes block, and within the high blood pressure block. And the reason we can trust that comparison is because all of the subjects are similar within those blocks. That means differences in outcomes, differences in satisfaction, or differences in health measures. We can believe that those differences are due to the treatment, the doctor or the nurse practitioner, rather than the underlying condition. So, last one, 78AB, the weight loss treatments. So explain why a randomized block design would be better than a completely randomized design. Well, without blocking, we would not be able to control for the effect of one's initial weight. So comparing weight loss between the treatments would be confused by the initial weight of the subjects. Think about this. If you start off with more weight to lose, it's possible for those subjects that initially have more weight to lose more weight. They've got more weight to lose in the first place. So the idea being, if we believe that the initial weight might confuse what we see in response to different weight loss programs, then what we need to do is control for that initial weight. Part B, should the blocks be of 4 formed alphabetically or by how overweight these subjects are by their initial weight? This is important. Blocks are always created based on something, in this case a characteristic we think will affect the response. Their names alphabetically won't affect the response, how much weight they lose. So what will affect how much weight they lose is their initial weight. Again, if they're more overweight, they have more to lose. If they are less overweight, there's less to lose. So the idea of blocks is to make groups of subjects that are similar, so that differences in response, they can be attributed to the treatments, to the different weight loss programs. So if our subjects are similar in terms of initial weight in the blocks, then all of those subjects, when we randomly assign them to different weight loss programs, any difference that we see in the total amount of weight they lose in that block, we can attribute not to how much weight they started with, but we can attribute it to the weight loss program that they were participating in.